let's start with the full adder. We know full adder is a combinational circuit that takes exactly 3 inputs, A, B, and then C in. It gives out 2 outputs, the sum and then the C out. The sum is equals to A XOR B XOR C, and C out is equals to AB plus BC plus AC. Since we are working with the NAND optimization, we have to rearrange the terms. If we do the traditional rearrangement, we need the min terms. So A XOR B XOR C can be given as A bar B bar C plus A bar B C bar plus A B bar C bar plus ABC. And if I rearrange this for NAND terms, this will look like A bar B bar C whole thing bar into A bar B C bar whole thing bar into A B bar C bar whole thing bar into A B C whole thing bar. And then we will cover entire thing with a bar. Here, if you look closely, A bar requires one NAND gate, B bar requires one NAND gate, C bar requires one NAND gate, and then here we will need another NAND gate, another NAND gate, another NAND gate, another NAND gate, and finally the entire expression will need another NAND gate. So totally we will need 8 NAND gates just for the sum part. And then we also have C out, we can't forget that. Here C is considered as the C in, don't forget that. C out can be given as AB plus AC plus BC in. Okay, let's say C in and C in, why not? If I rearrange this, I will get AB dot AC in dot BC in. And here we will have the bars and then finally the entire bar. Since we are not working with we are not working with signals that can be reused. For example, here we have ABC whole thing bar, and here we have A B bar C bar whole thing bar. Nothing can be reused here. So we will need 4 NAND gates totally for the C. 4 NAND gates totally for the C out. Now, if we use 12 NAND gates for a full ladder, it's fine. Okay, it's fine. But if there is a better way, why not learn it? Instead of 12 NAND gates, we are only going to use 9 NAND gates to create the full adder. And to do this, you have to have a basic understanding on how to create XOR gates only using NAND gates and how it is done by using only 4 NAND gates. So let me show you that quickly. If you have A and B, what we have to do is we have to send A and B through a NAND gate. Then A dot B, this is A dot B, right? This is A dot B whole thing bar. A dot B whole thing bar is sent through another NAND gate, but along with A. Then A dot B whole thing bar is sent through another NAND gate along with B. Now you should know how to make an XOR gate by using only 4 NAND gates. Here we will send these 2 intermediate outputs through another NAND gate to come up with A XOR B. That's it. This is how you have to create A XOR B. These intermediary steps result in the final A XOR B. Now, if I do this, okay, with C in, okay, if I do this with C in and A XOR B, I will get A XOR B XOR C in, right? So let me do that. So here we have A XOR B, and let me put a dot here, and here we have C in. We can send them through a NAND gate, okay, and he will be here waiting for C in again, and then also A XOR B again. This will be C in, and that will be sent through another NAND gate, Then we have A XOR B going through another NAND gate along with the intermediary, which is the A XOR B into Cn whole thing bar. These guys will be sent together inside another NAND gate to create A XOR B XOR Cin. That's it. This is what we need for the S. This is what we need for the S of full adder. Okay. Now what we have to do is we are going to send the A dot B whole thing bar, which is this one, A dot B whole thing bar, which is this one, and A XOR B dot Cin whole thing bar through another NAND gate to create C. I am only going to explain how this works here. Okay, so this is A XOR B dot Cin whole thing bar, this is C out, and this is A dot B whole thing bar. How does this create AB plus BC plus AC? Well, let's do that in the next step. Let's understand this. Let's analyze this. And so here C out is given as A dot B whole thing bar into A XOR B into C whole thing bar. So if I break the bars, I will get A dot B whole thing bar plus A XOR B into C whole thing bar. And we know according to double complementary law, these two will be cancelled. And here we have A dot B plus A XOR B into C. And this can be given as AB plus AB bar plus A bar B into C. And that is equals to AB plus AB bar C plus A bar BC. If you had watched the last video, we know this reduces into AB plus AC plus BC. I'll pin the link for the last video and you will be able to understand this. And this is how in industry we use only 9 NAND gates to create a full ladder rather than 12 NAND gates. I hope you understood, and in the next video we will be doing the same thing. We'll be optimizing the full ladder but by using only NOR gates. So don't forget to watch that video also, and I'll meet you in the other video. Thank you for watching the video on how to create full ladder by using only 9 NAND gates. If you found this video helpful, don't forget to like, share and subscribe for more lessons. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.